Welcome to This Explainer. Today, we're stepping into a seriously high-stakes digital battleground. How networks defend themselves against cyber threats that just keep relentlessly evolving. We're going to trace the entire evolutionary arc of network security today, looking at how our digital defenses have grown from, simple pattern matchers into highly intelligent, predictive systems. Okay, let's dive into this with a really fundamental question. If firewalls basically act as the locked doors of the internet, how are cybercriminals consistently bypassing the perimeter? I mean, a locked door is only as good as the person holding the key, right? And sometimes, threats just slip right past. That is exactly where we need a deeper, much smarter level of security. So, what does this all mean? Enter the Intrusion Detection System, or IDS. This is your continuous network monitor. It's constantly scanning for malicious activity or internal policy breaches, and it fires off alerts the very moment something slips past the perimeter, or even worse, originates from inside. It acts as an absolutely crucial second layer of defense. Think of it kind of like a classic castle defense. Your firewall is the giant wooden front door. It's binary, it's rigid. It either lets traffic in or it blocks it completely. The IDS, on the other hand, is the internal security camera. It doesn't actually block the intruder itself, but it watches, it records, and crucially, it alerts you the literal second someone starts acting suspiciously inside the network. Now, a network IDS, or NIDS, gives us this broad, eagle-eye view. Strategically placed at tactical points just inside the firewall, it acts as a massive checkpoint. It monitors all the inbound and outbound traffic flowing to and from every single device on that trusted network, matching that traffic against indicators of known attacks to instantly generate an alert if something looks off. Now, what's really interesting about this slide is how the strategy shifts entirely with a host-based IDS, or HIDS. Instead of sitting at a central choke point, a HIDS is installed directly on your individual endpoints. We're talking your servers, your personal computers, your specific devices. It monitors internal operations, tracking file status for any unauthorized tweaks, and catching those sneaky insider threats or compromised machines right from within the organization itself. All right, let's look at the first major step in our evolutionary arc: catching the known through pattern matching. This brings us to the Signature-Based Intrusion Detection System, or SIDS. SIDS basically operates exactly like a digital wanted poster. As traffic flows through your monitored environment, the detector literally examines the packets and compares them against this massive database of signatures. These signatures are specific patterns, like a known sequence of malicious instructions used by a specific virus. If the traffic matches the wanted poster, boom, the system triggers an alert. It's highly effective, for sure, but it relies entirely on having that prior knowledge. And honestly, that reliance on prior knowledge creates a massive critical blind spot, because SIDS absolutely cannot protect against what it has never seen. This introduces the genuinely terrifying concept of zero-day threats. A zero-day threat targets a weakness in software or hardware that is completely unknown to the vendor or developer. Because the threat is brand spanking new, there's no signature in the database. To a signature-based IDS, a zero-day attack just looks like completely normal unflagged traffic walking right past the security camera. And to make matters worse, hackers actively exploit this rigidity using some really clever evasion tactics. Let's run through 3 of the most dangerous ones. First up, fragmentation. This is where they split malicious payloads into multiple packets or add pauses, basically hoping the system just times out while trying to reassemble it. Second, obscurity. This involves deliberately manipulating protocols to use unexpected ports, slipping right under the radar. And finally, low bandwidth attacks. This is where they spread an attack out across tons of sources over a really long time, so their malicious scanning looks exactly like normal, benign background noise. Because criminals are constantly changing your disguises, we desperately needed our next major evolution, spotting the unknown through network behavior analysis. This is where we transition from SIDS to AIDS, the anomaly-based intrusion system. Where our old signature-based system looks for known bad patterns, an anomaly-based system focuses on defining what is actually normal. It establishes a baseline of trustworthy network activity. So once it knows exactly what a standard Tuesday afternoon looks like, it continuously compares live traffic against that baseline. If a device suddenly starts downloading massive amounts of data at 3 a.m., AIDS flags it as an anomaly, regardless of whether a known virus signature is present or not. And this brilliantly illustrates how that behavioral profiling actually works in practice, relying on algorithms like the AP chain. The system isn't just looking at the payload anymore, it's analyzing packet attributes. It's studying flow duration, packet sizes, connection frequencies, and response times. By extracting all these attributes, it creates behavioral profiles to detect complex, completely unknown attacks, like command and control channels or IP spoofing, without ever needing a traditional signature. But anticipating a thief's next move requires a highly adaptable guard. So let's look at the ultimate smart defender, machine learning. By incorporating machine learning into behavior analysis, modern intrusion detection systems can now differentiate between various types of network applications with an accuracy level that frequently surpasses 90%. No way, right? It's incredible. Machine learning models achieve this by instantly collating and analyzing vast data sets from numerous sources, identifying these incredibly subtle, complex patterns that a human or even a static algorithm would easily miss, predicting malicious conduct in real time. Let's move to and see how this builds out when we look at the empirical data. ML research for IDS from 2015 to 2018 shows a very clear priority. A massive 65% focused on classification, which is basically teaching the AI to look at a highly complex stream of traffic and instantly classify it as benign or malware. Another 23% focused on feature selection. That teaches the AI to optimize and focus only on the most important characteristics of the data, which makes detection a whole lot faster. And then we see feature transformation and clustering making up the rest. Finally, we're seeing the defense systems themselves become truly collaborative. While 56% of approaches used a single machine learning model, a rapidly growing number are utilizing hybrid and ensemble approaches. Actually, a hybrid approach combines entirely different algorithms to complement one another, while an ensemble approach goes a step further and merges the predictions of multiple models to significantly enhance accuracy and resilience. By combining these AI models, we're creating a highly robust defense system capable of dealing with dynamic, real-world cyber threats. So we've journeyed from basic firewalls all the way to AI-driven behavioral analysts capable of predicting entirely unknown attacks. But in the relentless cat-and-mouse game of cybersecurity, evolution literally never stops. Which leaves us with this final, somewhat chilling thought to consider. As our intrusion detection systems use machine learning to catch every single threat, how long is it until the threats start using machine learning to hide? Keep learning, stay curious, and thank you so much for joining me on this explainer.